Okay, just forewarning you, this one's more difficult, so get ready, okay? So now we're looking for f of g, which is the same as f of g of x, which is the f of x function with g of x plugged in for x. So f of g of x is the square root of the square root of x squared minus 1 minus 2. We cannot simplify that anymore. All right. So now we need to try to find the domain. So step 1, my inside function is g of x equals the square root of x squared minus 1. For this radical function, what's inside my square root must be non-negative in order to get a real number. So that tells us that x squared minus 1 must be greater than or equal to 0. Now that we have a degree higher than 1, we need to factor x plus 1, x minus 1 is greater than or equal to 0. My key numbers are positive and negative 1. So now I'll do my number line to check where this polynomial is positive. So if I pick a number less than negative 1, I get a negative times a negative, which is a positive. If I choose a number between negative 1 and 1, I get a positive times a negative, which is negative. And then greater than 1, I get a positive times a positive, which is a positive. So that tells us the domain for my inner function, g of x, where it's greater than or equal to 0, is from negative infinity to negative 1, union 1 to infinity. Okay. So now I need to look at my composite function, step 2. That is f of g of x, which is the square root of x squared minus 1 minus 2. A little crazy, right? Now, what's inside of this overall radical must be non-negative in order to create a real number. So that means that the square root of x squared minus 1 minus 2 must be greater than or equal to 0. Now this is a little crazy. We're going to have to manipulate it some to create a polynomial. So I'm going to isolate my square root. And then to cancel the square root, I can square both sides. So now I have x squared minus 1 is greater than or equal to 4. Or x squared minus 4, or x squared minus 5 is greater than or equal to 0. I cannot factor that more. So in order to find my key numbers, right, that's when x squared minus 5 equals 0, x squared equals 5, x equals plus or minus square root 5. So now I need to check my number line to determine where this polynomial is greater than or equal to 0. So let's think about less than negative square root 5. Just so we can think of this, x could be negative square root 9, right? Which is just negative 3. So if I plug that in, I get 9 minus 5, which is positive. For this middle interval, I can let x equal 0. I get 0 minus 5, which is negative. And then for this interval, I can let x equal square root 9. If I plug that in, I get 9 minus 5, which is positive. So my domain of f of g of x is from negative infinity to negative square root 5 union positive square root 5 to infinity. So now I need to check the intersection of these two intervals. So my first one was from negative infinity to negative 1. Right here. And from 1 to infinity. And then my second one was from negative infinity to negative square root 5. So negative square root 5 is going to be bigger than negative square root 1, or a bigger negative number. So negative square root 5 on and square root 5 on, right? So where we're looking at is where they overlap, their intersection. So the overall domain where they intersect is from negative infinity to negative square root 5 union square root 5 to infinity. So do not assume that it will always be the domain of the composite function. It is not true that it'll always be the domain of the composite function. We'll see more examples, but we always look for the intersection.